This taxonomy map categorizes the entire React ecosystem. Notice that React itself sits under the engine category, not framework. It is an open-source, component-based JavaScript library that functions strictly as a state-driven scheduling engine. To understand why the engine is designed this way, we have to look back to the early 2010s. Facebook engineers needed a way to manage massive, dynamic social media feeds without the entire page grinding to a halt when new data arrived. They built a solution around a specific syntax called JSX. A common trap in technical interviews is calling JSX a templating language or HTML. It is strictly syntactic sugar. This split screen reveals what happens under the hood. HTML-like tags on the left mechanically translate into a React.createElement function call on the right. Look at the resulting properties: type, props, and children. This immutable object, a React element, is the architecture's smallest building block. UI development in React requires stepping away from the concept of writing markup. You are writing logic that generates trees of immutable JavaScript objects. The central performance bottleneck in modern web development is the browser's document object model. Directly modifying real DOM nodes forces the browser to recalculate layouts and repaint the screen, which blocks the main thread. React bypasses this by maintaining a virtual DOM. This is a lightweight, in-memory representation of UI state, completely detached from the browser's heady rendering constraints. On the initial render, React reads your elements and builds the very first virtual DOM tree. When state or props change later, React does not mutate that original tree. It generates a new parallel virtual DOM tree reflecting the updated UI. This diagram illustrates the diffing algorithm. Comparing the previous virtual DOM on the left with the new tree on the right, React calculates the minimal set of updates. During the reconciliation phase, only those targeted nodes commit to the real DOM, leaving the rest untouched. Do not confuse this in-memory diffing process with the shadow DOM, which is a native browser technology used strictly for encapsulating CSS and variables in web components. To handle this diffing at scale, React 16 introduced Fiber. This rewritten reconciliation engine breaks rendering work into interruptible chunks. It allows React to pause rendering, prioritize high-urgency updates like user clicks, and resume background tasks seamlessly. React's perceived speed is a calculated illusion. The engine itself doesn't execute DOM updates faster than the browser. It applies strict algorithms to ensure it communicates with the browser as rarely as possible. The way developers interact with this engine has evolved. The industry has largely abandoned object-oriented class components and their complex lifecycle methods in favor of pure function components. Regardless of how a component is written, data must flow strictly downward from parent to child. Within this flow, props are immutable inputs passed down, while state is mutable local memory controlled by the component itself. When two sibling components need to react to the same changing data, you cannot pass state horizontally. You have to lift the state up to their closest common ancestor and pass it back down as props. This unidirectional constraint guarantees predictability. Because data never organically mutates upward, a child component must rely on explicit callback functions provided by the parent to trigger any upstream changes. Moving to pure function components required a new way to tap into the engine's internal memory. Hooks provide that bridge, allowing stateless functions to access React's rendering lifecycle. The most common is useState. When updating state that relies on previous data, relying on the raw state variable can lead to stale values. Developers pass an updater function into the state setter to ensure React always calculates from the most recent accurate state memory. There is one unforgivable error when using hooks, placing them inside conditionals, loops, or nested functions. They must be called at the top level of the component, in the exact same order every single time. This memory mapping explains why the rule exists. React doesn't identify hooks by their variable names. It maps local state to a hidden array index based purely on the sequence in which the hooks are called during the render phase.
When state logic becomes deeply nested and requires multiple subvalues to update together, useState becomes clumsy. useReducer solves this by externalizing the logic into a standalone function, handling updates via dispatched actions, much like Redux. For operations that reach outside the React engine, like fetching network data or manually tweaking the DOM, we use useEffect. This hook isolates side effects, ensuring they execute strictly after the render phase is completely finished. Occasionally, you need to bypass the render cycle entirely. useRef acts as an escape hatch, allowing you to persist values across renders without triggering an update, or to grab a direct reference to a raw DOM node. By utilizing this hook architecture, developers achieve complete modularity, cleanly decoupling complex state management and side effect logic from the visual presentation. This separation of concerns extends to form inputs. In a controlled component, React state is the single source of truth dictating the input's value. In an uncontrolled component, the browser DOM manages its own internal state, and React simply queries it via a ref when necessary. To handle user interactions reliably across all environments, React wraps native browser events inside synthetic events. This cross-browser wrapper guarantees that methods like prevent_default execute identically on Chrome, Safari, and Edge. When components need to return multiple sibling elements, wrapping them in an extra div pollutes the DOM and breaks CSS layouts. Fragments solve this, grouping children in the virtual DOM without adding extra nodes to the real DOM. For visual elements like modals or tooltips that suffer from CSS stacking issues, portals offer a clean exit. They allow you to maintain the logical component hierarchy in React while physically rendering the children into a completely different DOM node.
React fiercely guards the virtual DOM, but these specific APIs are provided as controlled escape hatches for the messy realities of the browser. As applications scale, strict unidirectional data flow hits a wall. Passing data through dozens of intermediate components that don't actually need it creates a bottleneck known as prop drilling. Redux eliminates prop drilling by pulling the state out of the component tree entirely. It establishes a centralized, single source of truth that any component can connect to directly. This circular track visualizes the Redux mechanical loop. A view triggers an action. The dispatcher sends that action to the reducer. The reducer, a pure function, computes the new state. The store updates, and the connected views re-render. While React's built-in context API also prevents prop drilling, it is best suited for simple, low-frequency updates like UI themes. Redux provides the rigid architecture and middleware required to manage complex, high-frequency asynchronous tasks. Global state management isn't a departure from React's core philosophy. It is simply unidirectional data flow scaled up and centralized. To build a complete single-page application, developers rely on libraries like React Router. It intercepts browser navigation using the HTML5 history API, swapping out React components instantly to mimic page changes without ever triggering a hard page reload. However, forcing the client's browser to download and execute massive JavaScript bundles before rendering any UI damages search engine optimization and delays the time to interactive. The industry solved this by moving rendering back to the server. These side-by-side network requests show the exact difference in delivery. In client-side rendering, the browser gets a blank shell and waits for JavaScript. In server-side rendering, the server executes the React code, and the browser instantly receives a fully pre-rendered HTML document. Next.js has become the ecosystem standard for this architecture. With the introduction of the app router, server components became the default, allowing the server to handle the rendering logic and ship zero client-side JavaScript for those specific parts of the UI. When facing a React interview, do not waste time memorizing exact API documentation. The ecosystem moves too fast. Instead, you must memorize the system constraints. If you understand virtual DOM diffing, strict unidirectional data flow, and functional composition, you don't need to memorize the answers. You can organically derive the solution to any React question a senior engineer can ask.